We have two presentations for you today. The first one is about a project that we've recently been working on called Workflow Elements. It's basically the next evolution of our architecture, and is how we're addressing scaling of our platform as we move further forward and get more users and more business processes on board. The second presentation will be done by my colleague Rob, and is about how we're using Camunda within our decision services platform within DMM. So, workflow elements. This slide was shared earlier, but this is kind of where we are in Goldman's in terms of the workflow platform today. The workflow platform is available firm-wide to every single user within the firm. So that's 40,000 total users. Luckily, they don't all turn up at the same time. But we think that we have somewhere in the region of 5,000 users, kind of as the time zones roll across on the line, actively processing workflows all of the time. That ends up creating somewhere in the region of 2 million new activities for people to be working on. We have 1,000 developers within the firm developing processes that run on our platform. So there's a significant number more developers developing on the platform than are developing the platform itself, and that also causes its challenges. But also, that's what makes the platform what it is today, and as a result, that's why we have these 14,000 active workflows being processed by our platform. And that's kind of what drives us on and keeps us going on this platform. So this presentation is basically a very brief run through the history of how we've evolved the platform. I've been with the firm for 8 years. When I joined the team, it wasn't the workflow team, it was the operations core team, and the tech team was there just to serve the operations department. Their goal that they'd started on prior to me joining was to create, firstly, a unified desktop for all of the operations users so that they could come in the morning, fire up their operations desktop, and they could do all of the work that they needed to do for the week within that kind of common environment. One of the other components that we soon realized we were going to need to be able to support that was the creation of a central task service. And so the team there created something called the work item service for operations. Now, the work item service was just a very simple, very large cache of work items. Work items were not really anything special. They just have associated with them a very simple state where they go from open to in progress to completed and to closed. And then the other components of the work item service were there simply to distribute the tasks into people's desktops, but primarily via a polling mechanism, or to provide an event stream of changes to tasks as they occurred, so that people could hook in their business in response to other actions. So that product launched. To kind of start driving up use of it, we created 2 programs ourselves. So the two applications we created on top of the work item service were a program called Checklist, which enabled teams within operations to define a checklist that would reoccur on a scheduling basis and would then be assigned to users in the firm, so they could then make sure that the things that needed to be done within the firm were done. Secondly, we created the email manager. The ops teams had a lot of work being coordinated via email. But email is not necessarily the easiest thing to coordinate this kind of stuff in. What we would do is digitize emails coming in from shared mailboxes, create those into work items, and then enable the operations team to see who was working on what via that process. So both of those applications launched. They both are still in use today by a significant number of users. But once we'd created those 2, it was then about bringing in the rest of the operations department, so that, or operations tech department, so that they could create their applications on this work item service platform. And then it became even more clear about some of the limitations we faced. So the big one was volume. Everyone kind of got the idea of having a single desktop. They all decided that they wanted to be in there as well. And then they all decided that they had 500,000 tasks that needed to be in the desktop at all times for people to do things with. So very quickly, we went from a very small little cache to a significantly much larger cache, and that introduced challenges almost immediately. The other thing was that while within our own applications we've been careful around making sure we had a life cycle around the tasks that we followed, that tasks came into existence, hopefully didn't stay around too long, hopefully got processed, hopefully got done, and then removed from the cache. Again, people trying to use our software didn't necessarily understand why that would be important, and so weren't necessarily so compelled to kind of follow that model. And so again, that kind of played back into the whole issues around and then supporting that platform and making it work for all of these users and all of these different use cases. So that was the first iteration. So I mean, the learning from there, we then took onto the next stage, really, to try and address some of this, and also it was widely discussed that BPMN was the way that we should be going to try and automate this stuff and provide all the kind of the good stuff we were talking about earlier in terms of collaboration, visibility, and understanding of processes. So to this end, we created a project called the Workflow Server. Now, the Workflow Server was based around JPMEM. It was a library that we created for developers to take to integrate into their own code to build a server that would then talk to the work item service and create tasks there. Now, along with this, we made great progress. In fact, we now have BPMN. We had the Eclipse modeler that came with JBPM. We integrated that and extended it so that teams could create the tasks as required. And that was a great step along this journey of BPMN. However, with it came the complexities of not only understanding JBPM, but also understanding our own libraries and how they worked. And that put off a significant number of our developers. They weren't keen necessarily to use JBPM. They weren't keen to run up their own services. And when we made changes, they were also less keen to then take our updated libraries and to deploy them. So what we found was that over time, that library model just became incredibly hard to support again because there was a lot of onboarding costs and then a lot of resistance to change as it was made. So now enters Camunda. So one of the other problems we had on the modeling space was the fact that to model any BPMNs, teams would have to install Eclipse and then install the Eclipse modeler. Now, we wanted BPMN to be something that tech and business can collaborate on, and unfortunately, getting the business to use Eclipse was not really the ideal tool. So at that time, we looked around to see what else was in the market, and we came across BPMN.io, and we saw how that could work and could facilitate both business and dev working together. And so from there, we developed the workflow engine based around Camunda, and so it is nothing really more than a wrapper around Camunda, and still talking and speaking to our central task service. So this is still the work item service as it was in prod ops. Now, at around about the same time, our focus as a team changed. We were no longer the ops tech team, and we became a central platform team for the whole firm. And so the prod ops stack was already at full capacity. And so we knew that we needed to scale horizontally very quickly to be able to support the entire business. So to do this, we created multiple instances of the same stacks. This was an entirely manual process that involved us ordering and deploying numbers of servers in entirely different configurations, unfortunately, many times, across the business. It was a painful task. It was error-prone. But we eventually got there, and we now have 8 kind of horizontal stripes running of the stack today. This then introduces the next problem, which is that the business don't want to know about stacks or horizontal partitions. All they're interested in is their tasks. And so along came the concept of aggregated services. So these aggregated services span across all of the stacks we've got and bring together views of the data to provide a single view on all of the workflows that are running across Goldman Sachs. It was also at this time that we realized that we could no longer scale the ops desktop UI, and we needed a new UI. And so at that point, we created eTask, which was an Angular web UI that would then surface all of this task data from all of these workflow engines. And so this is largely kind of where we are kind of to about 2 months ago. This stack has served us well. It kind of got us basically to where all those numbers are that we see at the start. It kind of makes sense to reflect on what we think worked out of that. Certainly, as we were saying in the panel discussion, the thing that really did work is model-driven development and taking on BPMN. For all of the reasons we discussed on the panel, it certainly helps that you can facilitate and communicate these conversations between businesses and users and tech on a common kind of footing ground. So a significant impact on this area was the fact that we moved to using BPMN.io, and we created our own workflow designer, which can be seen up there. As well as that, we also created our own forms designer, so again, we could involve more of the business as possible in that process. Also, key to all of this, and something that we think is integral to supporting a platform of this scale, was the SDLC process. It's vital that all of these processes are reviewed, that they're properly checked in, properly tested. We created a whole Cucumber testing framework so that people can execute their BPMN, assert the things are happening and the things are working all as to be expected. Okay, so the next step was workflow elements. We kind of hit another scaling limit. We'd been through the pain of creating all of these horizontal stripes. We realized the limitations of all of this manual work. What we wanted to do was to move away from having these shared task platforms that could potentially grow and scale outside of control. And what we wanted to do was to give teams a single unit of execution. What we also wanted to do was to empower them more to own that, to still host it for them, but to give them more control and more flexibility in terms of how it was run. So to that end, we very much simplified the architecture that we had. The work-time service and the core service had kind of grown over time to become some big monolith that we were no longer interested in. We chopped away at a vast swathe of that code and took it down to just the simple task engine library that formed the basis of what we actually cared about within the work item service. We took that library out, put that alongside into a process with the Camunda engine, and that kind of gave us the two elements that were the starting blocks of this workflow elements process, having tasks and processes living in the same engine side by side. So to empower teams to be able to have these engines, we looked at ourselves and we looked at our use of BPMN, and we realized that we kind of long bemoaned the lack of deployment technology within the firm to automate all of the different parts of the deployment activity. And so we went ahead and created the Workflow Control Center, which uses BPMN to orchestrate all of the deployment steps to create us a new instance of an engine. So today, now, people can go into the Workflow Control Center. They can click a button that says they want a new Workflow Elements engine. We review it. If it looks OK, then we click some buttons, and off the process goes. It goes around. It speaks to DNS services. It speaks to DC provisioning. It speaks to security, certificate generation, et cetera, et cetera. And at the end of it, we end up with a fully deployed instance of the Workflow Element engine running with the task engine inside it. Now, kind of the next step of this is obviously to move to containers. And when the firm's infrastructure is there, that's exactly where we think we're lined up and ready to go. It's just a question of making sure that the infrastructure is there and making sure that we can integrate with the deployment platforms when we're ready. But again, we think we're in the right place for that to happen. So outside of that, the Workflow Control Center enables a few other functions to help teams support their engine. So we've got full metrics, so you can see number of processes, number of tasks, CPU usage, all that kind of stuff, so that teams can now take an engine, they could now deploy it as a performance engine, they could test it to their capacity, and they can understand what the limits and the performance characteristics of that engine are. And again, that's something that they've continually asked for when, before we've had shared engines. It's very hard for teams to predict what the workload of that engine is going to be, and so therefore what kind of performance they're going to get from it. The other thing that we've been able to do is to provide full system logs. Before, we had to filter those by kind of process instances and stuff like that. Now we can show the full logs to all the teams, so they can support the engine much better. Okay, and so then this is what the kind of overall architecture looks like now. As you can see, we've still got the old engines. We've still got the central task services. We still have applications such as checklist and email that still speak directly to the central task service, and they don't have any of the BPMN orchestration. So we've maintained a layer of backwards compatibility throughout the kind of 8 to 10 years that this project's been under development, and that's certainly also been one of the things that has kind of helped us get to the point where we are today. So that's it. That's workflow elements. I hope that's been interesting. I'm going to hand over to Rob now, who's going to talk about DSP.
Thanks, Steve. So yes, I'd like to talk a little bit to you about decision modeling. So for anyone who's not quite as familiar, maybe as BPMN, decision modeling is a sort of a complementary practice, focused rather than sort of on the BPMN side, focused on modeling procedures of steps and sequences of activities. Decision modeling is focused very much on sort of individual, stateless, declarative decisions that need to be made. And sort of in contrast, perhaps to BPMN, these are typically very small atomic decisions. They may execute in milliseconds, microseconds, and we typically sort of embed them within the scope of a BPMN to sort of execute multiple of these decisions and come to some conclusion. Within GS, we have adopted the DMN modeling standard, which is sort of the de facto standard at this point. And we're sort of using Camunda at multiple levels within that process. So first of all, from a platform and an infrastructure point of view, we have what we call the Decision Services Platform in GS, DSP. This is a firm-wide, globally distributed platform for execution of decision models. The platform itself, sort of, as you can see here, it sits behind a REST endpoint with HA proxy routing regionally, and we divide this capability up based on geographic region. So we have self-contained Americas and the Asia clusters. Within each of these clusters, we have a collection of compute nodes, each of which is effectively able to perform the full set of decision execution activities that we need for all of our use cases. So these nodes are sort of functionally near enough identical. This sort of, as a consequence, the cluster is sort of horizontally scalable. We add nodes, we reshape clusters as we need to based on demand and based on use cases. And it also sort of affords us a pretty high level of resiliency. If one of these nodes were to go down, we effectively just continue to service all requests through the other nodes in this cluster with just obviously a somewhat reduced capacity until the node comes back up. And this is really crucial because, sort of as I'll come to a bit later, sort of the DSP and the decision modeling has become really sort of a mission-critical part of the GS infrastructure. We have a wide variety of use cases and business units running on the platform, and we have to maintain this sort of 24/7 uptime, no disruption of service at any point. In terms of the scale, so at the present day, we are currently executing around 160 million decision models per day, and that's sort of across around 2,500 distinct models. The growth itself has been quite fast. So as you can see here, we started around 100,000 executions per day in 2015, and then this has escalated fairly quickly through the millions to today, when we're looking around 160 million. Part of the reason, I think, for this growth is that the use of decision modeling has really, in a similar way to BPMN, as Steve mentioned, the use of decision modeling has really opened up the ability for members of the business or subject matter experts in different divisions to basically build their own decision logic and implement their own decision logic without necessarily relying on a technology team to do the implementation for them. Now, if we to focus in a little bit on just one of these nodes, each of these nodes it contains multiple rules engines for implementations of sort of slightly different scenarios. There is sort of supporting infrastructure within each node, and then there is this orchestration element. And this orchestration within each of the nodes is one of the places where we're using Camunda very extensively now. So to go into a little more detail, what we found as we were starting this process is we would initially have sort of fairly simple use cases. A business would define some decision. They'd say, here is a bunch of data. Here are a few rules that I've defined over the data. Please give me some conclusion and generate some data that you pass back to me. But as the usage started to grow and the uptake increased across the divisions, we found that we were increasingly looking at more complex use cases and people trying to do more sophisticated things with the platform. As an example, previously we'd have teams who would issue some request to execute a decision. They'd get a response from the platform. They would then do some computation on their side. They would construct some other request, and they'd send another request off to the platform, and that would come back. And they may repeat this 5 or 6 times. Now, in some cases, that's OK, but it obviously has a couple of disadvantages. One is sort of from the performance angle. Some of these use cases, we use DMN across pretty much the spectrum of Goldman's business processes. So this can range from sort of fairly mundane decisions which have no real pressure for execution to sort of trade-level execution where we need to guarantee a response within, say, under 1 millisecond. So for those kinds of use cases, we sort of that old model of sort of back and forth between the platform and the business teams was not sufficient. So we looked for a solution to sort of do some level of orchestration on the platform to run multiple decisions in a sequence with dependencies and sort of gateways and that sort of thing. And we settled on Camunda. Now there were sort of a few considerations for this. The first, as I mentioned, was performance. So we were looking for a highly performant solution. We were looking for something that we sort of has that we know will work well, and we have fully tested. And as you've seen, we make heavy use of Camunda within our process workflow engines. And finally, we recognized quite early in the process, we sort of recognized that we don't necessarily need the full expressive power of BPMN for what we're doing here. When we analyze the things that we do within these executions, it's typically very simple. It's run this decision, retrieve some conclusion, and then if it's X, do this, if it's Y, do this. Or if it's X, get some data from here, and then continue with the process. So to do this, we only really need a subset of BPMN. And quite importantly, we realized we only needed a subset of stateless components within BPMN. Effectively, all of our executions, all of this orchestration is stateless. It either completes fully or it fails. And each of those executions can be considered atomic. So when we were making this, sort of doing this analysis, we wanted to do an implementation where we have the ability to make some of these customizations within the scope of the APIs and the libraries, but so that we could sort of tailor it to this specific use case. So, as I mentioned, we chose to adopt Camunda, and we effectively did what I just described. So we implemented a version of the Camunda process engine within these the decision services platform on every node. And we performed this customization largely through the sort of configurable aspects of the Camunda libraries. So we were able to limit ourselves to the subset of components, as I mentioned, which were stateless. This also then allowed us to remove the dependency on any external shared databases, because we have no dependency on other nodes. Everything is atomic. If one node is doing something, the other does not care. So this allowed us to remove our dependency on any shared databases, and obviously the sort of potential performance issues that can cause. And we switched to using just single in-memory databases at the host level. We were also able, again, through sort of the customization available in the Camunda process engine, we were able to implement some of our own custom components and also some custom stubbed components where we didn't need certain functionality. So an example is here. In terms of serialization, which can sometimes be quite a heavy process, we don't require serialization of these potentially very large and complex decision models because we're not persisting them to any database. So we were able to stub this process, switch it off, and not pay the cost of doing so. We also, sort of in terms of designing these processes, we still want our users to be able to construct them easily. And so we built this integration into our existing workflow designer, which is the tool that Steve showed earlier for design of BPMN models. And obviously, this is using the BPMN IO libraries. We were able to add those few customizations, as I mentioned, sort of the custom fields for database connections, external data sources, that sort of thing. And then this is implemented in our design environment. So the users are able to specify these models, whether they have a tech background or a business background. On the topic of the design environment, we just talked about the orchestration aspect, which is quite close to BPMN. It's very close to BPMN. We've also more recently adopted the Camunda DMN.js library for rendering of the individual decision models that are being executed on the platform. So to date, we've been using an external modeling application to define these models. But what we've been able to do more recently is using the DMN.js library, we've made this available in the same design environment that we use for BPMN and also now for decision flow. We allow the users to actually construct these decision models in the application. Now, this is sort of partly a rendering ability, but we also, because we control this designer, we're also able to integrate this directly to the decision services platform itself from an execution perspective. So the users are now able to come into the design environment, construct one of these models, upload a file of, say, 100,000 test cases, test scenarios, and then those tests will be pushed off to the platform and distributed amongst those nodes, executed, returned, displayed in the UI, and allow the users to effectively execute in bulk against the platform in a purely testing environment, as part of their modeling process. Now, this was very significant for us because in the past, the route to getting from a decision that you model in this offline application through to running anything on the platform, it always involved some technology teams. We had an SDLC, which was sort of partly driven by technology, and at that point where we transitioned from model into code, there would be a technology team involved to sort of help perform that deployment. What this has allowed us to do for the first time is say those SMEs, those business users who are constructing the models, can actually run directly against the platform without even calling a developer in any way. And sort of, I think, we've seen very, very rapid uptake, and I think this has contributed to some of the growth of the platform itself, because using sort of these capabilities, we now have, sort of maybe the sign that this is succeeding is we occasionally talk to, or I often talk to, say, financial analysts or operations users who have constructed an entire set of decision models and a decision flow, put it all together, run it against the platform, and it either works fine or they have some questions, but they've done all of that without any external involvement. So that's really what this has allowed us to start doing. We are still extending this capability. So as I mentioned, right now, there is still an element of modeling done in external applications, but we are sort of extending this to the more recent enhancements to the DMN.js library to support modeling and modification as well. As we do this, we're sort of where it sort of makes sense, we are obviously considering contributing back to the library, because we're facing challenges that probably many people will face doing the same sort of thing. Now, going for a second from sort of this was obviously the modeling view, and we talked a little bit how we orchestrate these things. But I'd like to talk for a second about how we actually run the individual components within one of these big orchestrated models. So as I mentioned, a sort of an individual decision model, so some stateless representation of a business decision. We have sort of, until quite recently, we've been executing in a sort of a general purpose and a very powerful rules engine. And this has served us very well. It's been very effective, and the numbers you've seen are sort of effectively running through that process. But what we have seen, as the scope has increased and the uptake has increased, is that these capabilities are being picked up by divisions and business units in Goldman at sort of the extremes of what we thought we could even possibly service in the first place. So, for example, at the extremely low latency end, we have teams who are now using decision modeling for sort of per trade evaluation as part of the trade flow. Now that's obviously, again, it has very, very stringent performance requirements, and we started to feel that our approach of using this general purpose rules engine was working, but we were going to hit a limit where the overhead, however small, the overhead of spinning up this engine for an execution that may take half a millisecond and then tearing down this engine every single time was potentially going to become a limiting factor. So we started up a project in GS to investigate whether we could sort of take a more direct route from model to code. What we effectively did was we developed a library which will take the DMN description, the DMN XML description of a model, which we can obviously retrieve from the DMN.js library, and it will code generate Java directly based on this description of the model. So the output, as you can see here, this sort of this flow, the modeler creates something, the Camunda library outputs this description, and then we can code generate this directly into a series of Java classes, which are, obviously from a developer standpoint, this is great because I can see exactly what is happening in that process. Now, at that point, our SDLC effectively takes these classes, we compile them to Java class files, we bundle them up into a jar, and then that jar is pushed off to the platform, and this is the artifact that's executed. So we're effectively running these models sort of directly within the DSP JVMs with very, very limited overhead. Now, we've called this library JDMN, and right from the start, we decided that we want to do this, but also we'd like to kind of make it available for others to contribute who have obviously a lot of expertise. So we have actually released this as an open source library under the name JDMN, and it's currently on GitHub. So just to wrap up on that note, I think from the performance angle, which was sort of the reason that we tackled that problem in the first place, we have seen sort of very significant performance improvements based on that implementation. So anywhere from sort of 10 to 40 times faster than our previous implementation. It's obviously dependent on the model structure and the complexity and things like this, but our lower bound for performance improvement was around 10 times. So it's sort of, I think we've pushed the threshold of the extremes that we can service through this platform quite a bit further down the road. So as I mentioned, we have open sourced this library, and I would just like to say, we support DMN 1.1, the 1.2 standard, which is shortly being released, and we do fully intend to support DMN 2.0 as well as it develops. So I just say please do feel free to contribute to that library. Feel free to check it out if you would consider it, or please do obviously get in touch if you have questions on the use of it. So with that, I think we're good. We'll take any questions.